Knowing the time is important. We need to know when to wake up, when to work, and when to rest. For most of human history, the sun and stars were our only clocks, but over time, people wanted more accurate ways to measure time. This desire led to the development of clocks, from simple sundials to complex atomic clocks. The journey of timekeeping is a fascinating story of human ingenuity and our ongoing quest to measure and manage this fundamental aspect of our existence. Knowing the time helps us organize our lives. It allows us to coordinate with others and make plans for the future. As societies became more complex, so did their need for accurate timekeeping. Trade, travel, and communication all benefited from the ability to measure time precisely. The development of clocks, therefore, went hand in hand with the progress of civilization itself. Early humans used the sun to tell time. They observed the sun's movement across the sky and noticed how shadows changed length throughout the day. This observation led to the invention of the sundial. A sundial is a simple device that uses the position of the sun's shadow to indicate the time. It consists of a flat surface called the dial and a gnomon, which is a thin rod or plate that casts a shadow on the dial. Another early timekeeping device was the water clock. Water clocks use the flow of water to measure time. One common type of water clock was the outflow clepsydra. It consisted of a bowl with a small hole in the bottom. As water flowed out of the hole, the water level in the bowl dropped. Markings on the inside of the bowl indicated the time. Water clocks were more reliable than sundials because they could be used at night and on cloudy days. The invention of the mechanical clock was a major breakthrough in timekeeping. The first mechanical clocks appeared in Europe in the 13th century. These early clocks were large and heavy, and they were typically found in churches and monasteries. They used a system of gears, weights, and an escapement mechanism to measure time. The escapement is a crucial part of a mechanical clock because it regulates the release of energy from the clock's power source, which is typically a weight or a spring. The earliest mechanical clocks were not very accurate. They often lost or gained several minutes each day. However, clockmakers continued to improve their designs, and over time, mechanical clocks became more accurate and reliable. The development of the mechanical clock marked a significant shift from relying on natural phenomena like the sun and water to measure time, to using artificial devices that could operate independently of the environment. In the 17th century, the invention of the pendulum clock greatly improved the accuracy of timekeeping. Dutch scientist Christian Huygens is credited with inventing the pendulum clock in 1656. A pendulum clock uses a swinging weight called a pendulum to regulate the timekeeping mechanism. The pendulum swings back and forth at a constant rate, and this regular motion is used to control the movement of the clock's gears. Pendulum clocks were far more accurate than previous mechanical clocks. They only lost or gained a few seconds per day. This increased accuracy had a profound impact on society. Scientists could now conduct experiments that required precise time measurements. Navigators could use pendulum clocks to determine their longitude at sea more accurately. The pendulum clock remained the most accurate type of timekeeping device for nearly 300 years. Section 5. From pocket to wrist, timekeeping on the move. As mechanical clocks became smaller and more portable, people began to carry them outside their homes. The invention of the mainspring in the 15th century allowed clockmakers to create smaller and more portable clocks. The mainspring is a spiral-shaped spring that stores energy and powers the clock. This innovation led to the development of pocket watches, which became popular in the 16th century. In the late 19th century, wristwatches emerged as a more practical alternative to pocket watches. Wristwatches were initially marketed to women as a fashionable accessory. However, men quickly adopted wristwatches during World War I, as they were more convenient to use in the trenches than pocket watches. Wristwatches have since become a ubiquitous accessory for both men and women. Section 6. Atoms at work. The quest for ultimate accuracy. In the 20th century, scientists developed atomic clocks, the most accurate timekeeping devices ever invented. Atomic clocks use the vibrations of atoms to measure time. Atoms vibrate at a very precise frequency, and atomic clocks use these vibrations like a pendulum to regulate the timekeeping mechanism. The first accurate atomic clock was built in 1955 at the National Physical Laboratory in the United Kingdom. Atomic clocks are incredibly accurate. The most accurate atomic clocks today lose or gain less than 1 second every 100 million years. This level of accuracy is essential for a wide range of applications, including scientific research, navigation systems, and telecommunications networks. Section 7. Time in sync, global networks and standards. Accurate timekeeping is essential for synchronizing events and activities across the globe. To ensure that everyone is using the same time, international time standards have been established. Coordinated Universal Time, or UTC, is the primary time standard by which the world regulates clocks and time. It is based on atomic time and is kept accurate to within 1 second by the addition of leap seconds. The development of global navigation satellite systems like GPS and Galileo relies heavily on precise timekeeping. These systems use atomic clocks on satellites to provide location and time information to receivers on Earth. Accurate time synchronization is crucial for many technologies we rely on daily, including financial transactions, air traffic control, and computer networks. Section 8. Beyond the clock face, timekeeping's impact. The impact of accurate timekeeping extends far beyond simply knowing the time. It has revolutionized science, navigation, communication, and many other aspects of modern life. For example, precise timekeeping is essential for conducting scientific experiments, measuring astronomical distances, and synchronizing power grids. Accurate timekeeping has also had a profound impact on our understanding of the universe. Einstein's theory of relativity, for example, showed that time is not absolute but is relative to the observer's frame of reference. This revolutionary idea has had a profound impact on our understanding of space, time, and gravity. Section 9. A timeless fascination, our enduring bond with time. From ancient sundials to modern atomic clocks, the pursuit of accurate timekeeping has been a constant throughout human history. The evolution of timekeeping devices reflects our ingenuity and our desire to understand and control this fundamental aspect of our existence. As technology continues to advance, we can expect even more accurate and sophisticated timekeeping devices to emerge in the future. Our fascination with time extends beyond its practical applications. Time is a fundamental concept that shapes our lives and experiences. We are constantly aware of time passing, and we mark our lives by significant moments in time. The development of clocks and other timekeeping devices has allowed us to measure, track, and manage time in ways that were unimaginable to our ancestors. The story of timekeeping is ultimately a story about ourselves, our curiosity, and our unending quest to comprehend the universe and our place within it.